Okay, about a week later, we have the new leaves are growing fairly well. As we can see, they are facing the lamp because most of the day it's the only light source. Still, sun is making some progress faster. As we can see, the other lemon tree has some new leaves coming, like here, and this is already getting bigger one, and these two here. The smaller lemon trees are doing... let me get the onions away. The smaller lemon trees are doing also quite well, although far from perfect. Let me see if this will adjust to the light. There we go. As we can see, the leaves are still wrinkled, but not that much yellow in the veins anymore, which is good. Although this one, this poor little bastard, is still having some problems. As we can see, this leaf here is having a yellow tip for some reason, and this one here has a brownish tip, which is kinda annoying, trying to grow these as best as I can, but at least they are still alive, so let's put them back in the sunlight. Then the smaller trees. As we can see, the tiniest tree is still extremely small. It doesn't grow, but it seems that it's still alive, so I'm not sure what's going on with it. And the other lemon trees are as they were about a week ago, so nothing's changed that much. And the onions, as we can see, there's some roots growing fairly well, and the shoots are getting bigger, which is always a good sign. They're still alive and doing well. This onion here is splitting apparently, as one could see. I'm waiting for the outer shell to dry out a bit more before I peel it off, just to see what's inside. But that's the botanic part of this week. I've been fertilizing them with a little bit of this stuff. It does show kalium nitrate, but it's potassium nitrate. As we can see, it's oxidizing, and it is over 98% potassium nitrate. Of course, I've been supplementing the potassium nitrate with this gross stuff, some form of substral stuff, but as we can see, if we can focus, it does contain N, P and K, nitrogen, potassium and phosphorus. It also has copper, iron, manganese, molybdenum, zinc. Pretty much everything the plants need, because at the moment they are in fairly dry, not dry, but unfertile soil. I've burnt, actually, it's old soil that I've burnt in the oven for a couple of hours to dry it completely and burn everything organic in there. So it's sterile. And it's here's some of it. It's fairly dusty, as we can see. It made my hand dirty. So it needs to be fertilized quite a lot, especially in the first times, because every organic matter here is pretty much just burnt. And then I'd like to talk about the grow lights I'm having. This fluorescent tube is a 15 watt, here's the ballast, 15 watt aquarium lamp. So maybe not the best suited for this stuff. And then there's of course this, there's a dimmer which will make the lamp either not glow or blink for a bit, if I can get it to blink, yeah. And then there's this other lamp which only has this nice little on-off switch. They are both LED lamps. They are iron LED grow lights, 6.5 watts, and here's the curve with the colors and the intensity. And yeah, well, they have been actually pretty good. They don't look as bad as those violet or pinkish violet grow lamps, so they don't strain the eye so much, but still, as we can see, the plants really love it. Of course, I created in school another grow lamp that I haven't actually been able to test because it's harder to mount, but I'm gonna show it to you next. So here we have, there are plenty of small 3-watt LEDs in 3 rows, with each having their own resistors. Each resistor is, as we can see, they are, as soon as this will focus, 3.9 ohms, 1.5 ohms, or that's the one down there, and then 1 ohm resistor. The 1 ohms are too low for these LEDs, so I haven't actually connected them to anything. But there are 3 strips of 1, 2, 3, 4, 5, 6, 7, 8, 9 LEDs, each of them consuming about 3 volts. I actually don't remember the exact value, but I did calculate that with the 33-ish volts my power supply can give, they will burn quite bright, but they are not going to burn themselves out. They are mounted on a aluminium heatsink, as we can see on the underside, that if it actually will focus. I'm using automatic focus, so yeah, aluminium fins. So I've tested it for extended periods and it will never get above 50 C, the aluminum, I mean. And yeah, as we can see, I did solder them, or glue them and solder them, so there is only a minuscule gap, so it's not meant to be actually wait if I can focus it at least a bit. Yeah, there's the crispy focus. As we can see, each and every one only has about a millimeter of free space between it and the aluminum. But I did use copious amounts of lacquer to insulate the aluminum. And of course there are some fins stolen from few computer power supplies. There were three of them, but the one didn't work, so I had to take it out. And they are all in series, as we can see. One of the cable goes to this one, and then the black cable is soldered to this orange cable and put some heat shrink and hot glue on. And then again the red cable of the other fan, and of course the sense wire I took out. And then the black wire is soldered to the main bus black wire, and the blue wire here is the negative side, and the positive side is always after the what are these? Resistors. And they are all in parallel, which means they will use roughly 70 watts combined when I use them in the red channel, which is the 1.5 ohms I think that's the brightest I'll go, because the 1 ohm will give them too much power and they will burn out, and well, they have been glued, so it means I will have to hammer them out, which would be not so nice. And the power supply, as badly as it has been built, is basically 230 volts in AC, goes to this toroidal transformer, from which the 2 secondaries are combined in parallel. They will go to this huge monster diode bridge, from which the capacitors have their own, they are all in parallel also. They have a negative and the positive lines coming out, and there's the discharge resistor I put in. And as we can see, each and every one of these capacitors is 2200 microfarads, so they are huge capacitors. So there will be minimal ripple at the roughly 2 amps and 33 volts, 30 volts. Roughly something like that. I did the calculations, but in the end I can't remember, even if my life depended on it. I'd have to do the calculations again. And nicely the toroid has its faceplate, or the information plate, somewhere in there. It's that white little part there. So as badly as it is built, it is still grounded. The case is grounded, and it's an old computer case. I took the insides out and swapped everything to be a rough power supply. I'd actually like to make there some form of switching or pulse modulation to control these LEDs for real, and adjust their brightness with Arduino, or maybe even some simpler microcontroller, or even 555 controller. But at the moment I don't have the tools nor the money to build actually anything, so I'm gonna put this all together and switch it on to show you how bright it is. So here's the thing running. As we can see, there are 2 colors of LEDs, because I did design this to be a plant lamp, so I thought there'd be better off if I had a couple of colors, because LEDs have a tendency to have extremely narrow color range, from what I read on the online somewhere. So this is the way I tried to compensate. There are a few bluer LEDs or color LEDs and some reddish or warm colors. Actually they'd be other ways. The warmer the Kelvin number, the bluer they are, because of blackbody radiation. But anyways, they are really, really bright. Here's the black alligator clip from the power supply. Oh, they're nice lens flares, I love them. And then there's the red alligator clip going to both the fan line and the actual resistor, which gets extremely hot fairly quickly. But that's okay, as we can see there are 2 fans blowing on it. Yeah, some nice effects. And it does have some nice shadows if we can see them, because there are plenty of those. Maybe they are not that easily to be seen, but there are plenty of small points of light, so they will have tons of sharp shadows, but there will be so many of them that they will actually blend quite nicely. They will make those thin looking patterns. But that's this day's botanic garden / electronic experimentation. Thanks for watching, please subscribe. See ya.